Hello everyone. In the yesterday's class, we talked about the system. We saw the definition of system, that is, a system is a set of elements or a functional block that are connected together and they produce an output in response with the input signal. Okay, so we have a signals, that is, we have a continuous signals and we have a discrete signals. So systems again classified as a continuous time system as well as discrete time system. This is just a further classification of systems. Okay. So continuous time system which handles only a continuous time signals. For example, we have analog filters like amplifiers, analog transmitter, receiver, etc. Okay, whereas discrete time system handles discrete signals only. For example, computers, your microprocessors are the example of the discrete time system. Then further, our continuous time and discrete time systems are classified as, you can say, classification based upon the properties. That is, you can say first property is dynamicity property, which will tells us about whether the system is dynamic or static. Then we have a shift invariance property, which will tells us about whether the system is time variant or invariant. And third property, these two property we have seen in the earlier class. The third property, that is linearity, fourth one is causality, fifth one is stability, and sixth one is invertibility, which we will see in this class only. So first one is your linearity property. So a system, so I will write the definition. A system is said to be linear. A system is said to be linear if if it satisfies the superposition principle. If it satisfies superposition principle. Now let us consider two systems. Let us consider two systems as y1 of t is equals to the function of x1 of t. This is the first system. The second system, y2 of t, is nothing but the function of x2 of t. Function of x2 of t. Then continuous time system defined as, or you can say it is linear if function of a1 times x1 of t plus a2 times x2 of t is equals to a1 sorry a1 y1 of t plus a2 y2 of t. Here a1 and a2 are constant. Okay, so see, we have two systems, that is y1 of t and y2 of t. Then our continuous time system is linear if and only if this your function of a1 x1t plus a2 x2t is equals to a1 y1t plus a2 y2t. This is nothing but your superposition theorem. So which tells us that the response due to x1 of t and x2 of t together is same as the sum of the individual responses for a linear system. Sum of individual responses for a linear system. Now this is in continuous time domain. Let us look for a discrete time domain. What is the definition? So it will be the same. The definition will be the same. So similarly, you can write similarly, the discrete time system, the discrete time system is said to be linear, is said to be linear if it satisfies superposition theorem. If it satisfies the superposition theorem. And what is that? It is tells us that combined response due to x1 of n, or combined response of two systems altogether, is same as the individual response of that system. That means let us consider we have y1 of n, okay, which is nothing but function of x1 of n, y2 of n, which is again nothing but the function of x2 of n, x2 of n. Okay, fine. Then discrete time system is linear. Then discrete time system is linear if function of a1 x1 n plus a2 x2 of n. Okay, this is the combined response, which is equals to individual response of the system, that is a1 y1 n plus a2 y2 n. Again, a1 and a2 are the constant, arbitrary constant. Okay, fine. So this is what is your third property, linearity property. Okay, if any system which does not follows the superposition theorem, then that system is called as non-linear system. This is the combined response of two systems, which is nothing but the individual response of the system. This is what the linearity, this is what the superposition principle. Let us take another fourth property, that is your causality. Okay, so which will tells us about whether the system is causal or non-causal. Okay, this non-causal also tells us that is anti-causal system, causal or anti-causal. Okay, this is again another name, that is causal and anti-causal system. Okay, so causal or anti-causal, or you can say causal or non-causal system. Let us see the definition first. Okay, so the system is said to be causal. The system is said to be causal. Okay, if its output depends on present and past input only. If its output depends on present and past input only. Okay, so remember this definition. This is very important concept, that is in causal and non-causal. The system is said to be a causal if its output depends on present and past input only, okay, and not the future input. Okay, so this system is called as causal system. For non-causal system, for non-causal system, it depends on future input also. Okay, I will write the definition. The system is said to be non-causal or or anti-causal, non-causal or anti-causal if and only if its output depends on present, past and future input only. Okay, so remember this definition. The system is said to be causal if its output depends upon the present and past input, and the system is said to be anti-causal if its output depends upon future input also. If its output depends upon future input also, that means it requires present, past and future input. Okay, understood? Now let us take examples. Example, this y of t0, this is your t0, that is output at t0. Okay, this remember, output at t0 is nothing but function of x of t, where t must be less than or equals to t0, where t must be less than or equals to t0. That means whatever the t's are there, those t's are less than or equals to t0. This implies, okay, this implies that output at any time instant, that is at t0, depends on the input before t0, depends on the input before t0. That means the system is called as causal system. Causal system. Another example, let us take in terms of discrete time system, that is y of n is nothing but function of x of k, function of x of k, where k belongs to or k is less than or equals to n. This is also a causal system. This is also a causal system. Let us take another example so that you will understand again. Y of n is equals to x of n plus x of n minus 2 plus x of n minus 4. Okay, so you can see that at n we require to get output. So yn, or you can say the output depends on, this is your present sample, this is your x minus 2, that is your past sample, x minus 4 is also your past sample, or you can say that it is a causal system because it involves, this is your present samples and these two are your past samples. Let us take another example. Y of n is nothing but x of n minus 1, this is your past sample, plus present sample plus future sample. Okay, so this is your anti-causal system. This is your anti-causal system because it involves your present sample, this is your past sample, present sample and then future sample. So this is your anti-causal system, or you can say non-causal system. Non-causal system because it requires future input because it requires future input sample. Okay, let us take another classification, further classification, that is your stability, or you can say stability, or you can say stable and non-stable system, stable or non-stable system. Okay, so the system, I'm writing the definition. The system is said to be stable. The system is said to be stable. Okay, remember here, if attention, make attention here, if for every bounded input, okay, for every bounded input, it produces bounded output. Okay, the system is said to be a stable system. For every bounded input, it produces the bounded output. And now what is the meaning of that? Let us see. Okay, so this system, so what is input is bounded means, write down here, if the input is bounded, if the input is bounded, that means that means there exists some finite number. If the input is bounded, that means there exists some finite numbers. Okay, finite number. Let us take, for example, let us take example at input side where, okay, there exists a finite number. Let us take it is mx. Okay, such that, okay, if the input is bounded, meaning what? Meaning is that if we take modulus of x of t, okay, and we must get the value to be finite. Let us take this is mx and it should be finite. This is for input. Okay, so that's why we are represented it at x. Okay, x of t, this is for x of t. This is in terms of continuous time domain. For discrete time domain, it is like x of n. It is also a finite, its value is finite, and it is less than infinity. Okay, so if the input is bounded, that means there exists some finite number mx such that mod of, or you can say magnitude of x of t, which is less than or equals to mx, and which is less than infinity. Okay, so there should be a finite number. This represents. Okay, similarly similarly the output is bounded. Now we have seen input is bounded. Similarly, if the output is bounded, okay, if there exists some finite number, okay, now this number is like my, such that magnitude of y of t, which is less than this number my and which is less than infinity. This is in continuous time domain. What is in discrete time domain? This is y of n less than or equals to my, which is less than infinity. Okay, so this is what the definition of stable system. What is the definition of unstable system? exactly the reverse. Okay, I will write the definition. So if the system is producing if the system is producing unbounded, unbounded means infinite, unbounded output, infinite output for bounded input, for bounded input, then the system is called as unstable system. Then the system is called as unstable system. Okay, so if the system is produces unbounded output, okay, unbounded means infinite output for finite input, then the system is called as unstable system. Okay, unstable system. Fine. The stable, okay, the stable system is also called, its other name is also called as bounded, capital B, bounded input, bounded output. Okay, that is BIBO, stable system, stable system. Fine. So now let us see the last one property, last. Okay, this is your invertible property, invertible or inversible also. Okay, the same name, or you can say non-invertible system, invertible or non-invertible system. So the definition, okay, so invertible system definition. So is said to be a system is said to be invertible if there is unique output, if there is unique output for every unique input. Okay, if the system is said to be invertible system if there is a unique output for every unique input. Okay, what is this meaning? What is this meaning? Let us understand. If the system is inverse, if the system is invertible, or you can say inversible, then for there must exist a inverse system. Okay, I will write in that way only. For the system to be inversible or invertible, then there exists inverse system. Okay, so what is invertible system? A system is said to be invertible if there exists, or if sorry, there is a unique output for every unique input. Okay, and for the system to be invertible there must exist a inverse system. Okay, let us take two system interconnected. One is your system, this is your system. Okay, so the input to the system is your x of t and it will produce your y of t. Fine. Now if another system is cascaded to this system, if the another system is cascaded to this system, we are calling this system as inverse system. We are calling this system as inverse system. And then okay, then what it will produce? It will produce the same as input. So you can see that here two systems are cascaded. One is system, okay, which is defined as H, you can say, and then inverse system is defined by H inverse. Okay, so x of t has been given input to this system, and it will produce y of t. Y of t has been given to the inverse of that system, and then it will produce the same, or you can say unique x of t, or whatever the x of t which we have sent to this system, it will produce the same x of t after the inverse. Okay, this is what the meaning, you understand. And if you calculate if we calculate this h into h inverse, we will get as 1. Okay, so that means there exists a inverse system. So this is what about this is what the today's class. So we saw all the system properties, or you can say classification of a system based upon the properties. Okay, in the next class we will see a few of the problems. Thank you.